Last episode, we turned whole sentences into single vectors and watched cosine similarity light up the pairs that meant the same thing. But back in episode 2, we built something we never fully cached in, the attention mask and the offsets that come with it. The little map that says token number 7 actually starts at character 12 in the original string. That map is exactly what lets us take a label the model assigns to a token and paste it back onto a word a human can read. Today we use it. We're going to point a model at a sentence, ask it not is this positive or negative, but what is each word, and get back highlighted entities. This is a company that is a place, and here's how confident I am. Token classification is a different shape of task from everything we've run so far. Sentiment gave you one label for the whole sentence. Here, every single token gets its own label. The model walks left to right and stamps each piece of the input with a tag, person, organization, location, or nothing special, move along. Same transformer, same forward pass, but instead of pulling everything down to one decision, we keep a decision per position. The classic flavor of this is named entity recognition, NER. Give it Apple opened an office in Paris and it should hand back two highlights. Apple is an org, Paris is the LOC, and the words opened and office in are just ordinary language with no entity to flag. NER is the workhorse behind resume parsers, news taggers, search indexers, anything that needs to know who and where a sentence is talking about. Here's the wrinkle that makes this episode worth its own file. The tokenizer doesn't think in words, it thinks in subword pieces. A name like Washington might split into Wash and Orderington. So the model labels pieces, not words, and if you print those raw, you get an ugly broken up mess. The fix is aggregation. Stitch the pieces of one word back together and give the whole word a single clean entity tag. Under the hood, the labels carry a little grammar called the bio scheme. B means beginning of an entity, I means inside, continuation of the one before, and O means outside, not an entity at all. So a two token city becomes block, then iloc, and the aggregator reads that as same entity, glue them. You almost never have to touch bio by hand, but when a span looks weirdly split, this is the grammar that explains why. Every flagged entity also comes with a score, the model's confidence, a number between 0 and 1. Apple as an organization at 0.99 means the model is essentially certain. A messier sentence might give you a city at 0.61, and that lower number is your cue to double check. The score is not decoration, it's the dial you threshold on when you wire NER into something real. And this is still the one-liner pattern from episode 1. We don't load a model, don't write a softmax, don't manage the bio grammar ourselves. We call pipeline or NER with one aggregation flag, hand it a string, and get back a tidy list of dictionaries, each with a word, an entity type, a confidence, and the character span where it lives. The whole heavy machine hides behind a single function call. Picture the payoff. The sentence sits on a clean white card, and two of its words are wearing colored boxes. Apple glows in a blue org frame, Paris in a gold LOC frame, each with 0.99 stamped beside it. The plain words stay dark and quiet. That single image is the entire job of this episode. Turn raw text into highlighted labeled scored entities. You could drop straight into a UI. Let's open the file. One script, 12ner.py, 2 short pages. Page 1 builds the pipeline and runs it on our sentence. Page 2 walks the results and prints clean, aligned entities. No training, no GPU needed. This is pure inference. Page 1, we import pipeline from transformers, then build a token classification pipeline. We pass model Sattva Deslim BERT Besner, a small BERT fine-tuned for exactly this. And the key argument, aggregation strategy, simple. That flag is what tells the pipeline to merge subword pieces back into whole words and collapse the bio tags for us. Then we define our sentence string. Apple opened an office in Paris, call the pipeline on it, and store the result list. Page 2 does the alignment and the printing. The pipeline already handed us word level entities thanks to aggregation. So each item is a dictionary with word, entity group, score, and the start and character offsets. Those offsets are the episode 2 map caching in. We loop over the results, round the score to 2 decimals, and print each entity as word type and confidence. We also slice the original sentence with start and end to prove the span lines up with the real text. That's the alignment made visible. And that's NER end to end. One pipeline call, one aggregation flag, and a loop that turns subword soup into clean, scored, highlighted words. We saw a company and a place pulled cleanly out of a plain sentence, each carrying its own confidence. NER labels every token, but sometimes you don't want all the entities. You want one precise answer buried in a paragraph. Next, we pull an exact answer, span, out of a passage.